All right, today's lesson is on scale factor and ratio. Just a reminder, with the video, you can pause it to make sure you get all the notes. You can also go back and listen to something or look at something again that you may not have gotten. So again, make sure you take advantage of that as you're going through the video here. To start with, we have this original picture that's 4 inches high by 6 inches wide. And then we have the enlargement, and the enlargement is 8 inches high. So the first question there is, what's the ratio of the height of the enlarged photo to the height of the original photo? Well, the enlarged photo's height is 8 inches, and the original is 4. So it's 8 to 4, but we can reduce that because we can take and divide 8 and we can divide 4 both by 4. When we do that, 8 divided by 4 is 2, 4 divided by 4 is 1. So the ratio is 2 to 1. So the next question there is, the height of the enlarged photo is blank times the height of the original photo. Well, since the ratio is 2 to 1, that means it is 2 times the height of the original photo. The width of the enlarged photo, we don't know that yet, but we're going to figure it out. So one way to do that is, we know that the original width is 6, and we know that the enlarged photo is 2 times the original photo. So we can just take this, the 6 times 2, and get 12. So we know that it's going to be 12 inches. And we'll just add that in here as well, the 12 inches. Now, if you kind of get stuck with that, you can always go back to a proportion. We know that the enlarged over the original is 2 to 1, and we know that the original is 6. So you can always go ahead and solve that proportion too. 6 times 2 divided by 1 would also give you the 12. So keep that in mind as you go through. You can always fall back on that. So either one of these works. Okay, you can do the 6 times 2 to get 12 or set up the proportion. The last thing here is the measured lengths of the enlarged photo are blank percent of the original measurements. Okay? So what we're going to do there to get the percent is just take that it's 2 times as big. Well, you can think of it this way. We can just take 2 times 100 because percent is out of 100. So 2 times 100, 2 times 100%, we just write that again. But if I take 2 times 100%, that's going to equal 200%. Okay? Or you can always fall back on the ratio and proportion. Again, our ratio is 2 to 1. If we're talking about percentages, we're always talking out of 100. So you could go ahead and solve that proportion, 2 times 100 divided by 1. To get the 200% as well. So that's how that works for an enlargement. Okay, now let's take a look at a reduction. So it says, suppose you want to create a new version of this picture using a scale factor of 1/2. What will be the height of the new version? So we know that we want it to be half of it. So if the height is 4, I can just take 4 times 1/2. And 4 times 1/2 is going to be 2. Okay, so I know that the height of this new version is going to be 2 inches. Okay, now again, if you can't pick up on that, you can always fall back on your proportion. Okay, so we have the original over the new. We want that to be 1/2. Okay? Or I'm sorry, I messed this up. This should be the new over the original. The new over the original is 1/2. So if the original is height is 4, I can just put that 4 there. 4 times 1 is 4 divided by 2 is 2. Okay? So again, the width of the new one, well, if the original is 6, okay, I can just take that times 1/2, and I'll get 3. So the width of the new one is 3 inches. Now the last part here, the measured lengths of the reduced photo are blank % of the original measurements. Okay? Now what I'm going to do to get that is I'm going to take my scale factor of 1/2, and I am just going to take, I'm going to go to the calculator here, 1 divided by 2 to get that as a decimal. Okay, so that's going to be 0.5. Now to go from the decimal to the percent, I'm just going to take 0.5 times 100. So in my calculator here, I can just say times 100, and that's going to give me the 50. Okay, so it's 50%. Okay. Another way you could do this is, again, you know your scale factor is 1/2. If you want to know what the percent is, that's out of 100. Okay. So you could solve this proportion, 1 times 100 divided by 2, and that would also give you the 50%. Okay. I'll rewrite that 50 there a little better. All right. Okay, moving on here. So this first part on here, we want to take note of when you enlarge or reduce a photograph, the ratio of the height to width remains the same. Each copy is proportional. Okay, that's what's important there to remember. And then moving down here in the blue here, plane figures and solids that are mathematically similar to each other have the same shape, but not necessarily the same size. Okay, that's what happens when we reduce or enlarge something. When you enlarge it, you make it bigger, still the same shape, you just blow it up. When you do a reduction, keep the same shape, you just shrink it. Okay, and then down here in the next paragraph, the definition of a scale factor, it's the ratio of the length of one side of a figure to the corresponding side of a similar figure. Okay, so that's when we took like the height of the enlarged picture and compared it to the height of the original picture. Okay, and we came up with that scale factor of 2. Okay. Now down here on the bottom, one thing I just want to take note of is it says that on photocopy machines and computer zoom settings, the scale factor is often written as a %. Okay? Now, one thing to note there is if it is greater than 100% is going to enlarge your picture or photocopy. If it's between 0% and 100%, it's going to reduce your copy. Okay, again, here was just another look at that example that we did with the first one with the enlargement. Okay, you can take a peek at that if you need to. Example 2 here is just again looking at the reduction that we looked at. Now getting on to the work time here, we're actually going to skip this first problem, which means We're skipping 2 and we're skipping 3 for now. And we're skipping this number 4, and we're going to go on to number 5 here with these pictures. Okay? So we need to figure out on these pictures what the values of all the letters are. So we need to figure out what A equals, what B equals, what C equals, what D equals, and what E equals. Okay, so I'm going to start, just looking at this, I'm going to start with B because I noticed that this side is 6 inches, and these B's go together to make up that same height. So each one of those B's must equal 3 inches. Okay, so I know B is equal to 3. Now, because I know B, the next one I could figure out here is C. Okay, because if I look at the big picture here, I know that the height is 6, and I know that the width is 4. Okay, so if I'm looking at the height over the width, I know I've got 6 over 4, and I know the height of the smaller one is 3, and I'm looking for C. So 6 times C is 6C, 4 times 3 is 12, divide by 6, and we get C is equal to 2. All right, so now I know what C is. I can go ahead and put the 2's next to all my C's, which is just the 1. Okay, so now that I know what C is, I can figure out A, because if this part is 4, right here, this is the same as A. So 4 and 2, that makes 6. So A is 6. Okay? All right, so moving over to the other side here, we still got to figure out D and E, and they're on this other picture. Now, I already know that B is equal to 3, so I can put those in there. Now, what you have to be careful of here is these pictures are tilted sideways. So I can still use height over width here. I know that the big one is 6 over 4. But now I have to be careful here because I can figure out E, but E is actually the height of that picture because it's tilted sideways. 3 is actually the width. So when I go ahead and do that, I can do 6 times 3 is 18. 4 times E is 4E. Now when I divide by 4 here, I'm actually going to get a decimal of 4.5. Okay? So now I know E is 4.5. And I can go ahead and figure out D now because D is the same as these two combined. So 4 plus 4.5, that's going to give me 8.5 for letter D. So now I have A, B, C, D, and E all figured out. To go ahead and wrap all this up here, looking at the last couple pages, a scale factor in your own words, I would just say it's a number you multiply the original dimensions by to get an enlargement or reduction. Going on to 7, says you can multiply the lengths in a figure by a scale factor to reduce or enlarge that figure without changing its shape. What's the result when the scale factor is greater than 1? The original is enlarged. B, what's the result when the scale factor is less than 1? The original is reduced. It's made smaller. C, what does it mean for the scale factor to be equal to 1? It means the original is just copied. You get the same dimensions again. So it's like cloning it. And then the last part there, you can go ahead and look at that if you need to. Not a huge deal. And then the last part here, describe the scale factor that results in an enlargement or reduction in a copy. Just what we just said, an enlargement, the scale factor is greater than 1. A reduction, the scale factor is less than 1. And a copy, the scale factor is equal to 1. Go ahead and finish these up, what you need to, and have it checked off so that you can get your homework sheet.